All right, then we have to discuss about the devices like your hub, router, and switch. Okay, now when we'll discuss about hub, there will be a word like it is a layer 1 device. Okay, so what is the layer 1, layer 2, all these things. So for understanding these layers, we'll have small introduction to the OSI model. Okay, so right now we'll not have the detailed overview of the OSI model because we'll have it in separate session. There is one complete session for the OSI. Okay, so right now what we need to know that, see, we have certain models. We know that, okay, communication is taking place, but we need to understand how the communication is happening in the background. Let's say you're going to your phone and then say typing a hi message to your friend, and that automatically gets delivered to your friend's phone in the WhatsApp application. But what is the backend process happening in between? That process we have to understand, because if you want to understand the communication, if you want to troubleshoot the communication, then we'll have to understand the backend process. So how we can understand the backend process? Using these models. Okay, so what are these models? If we discuss, we have certain models like there is a TCP IP original model, also known as DoD model. There is a TCP IP original model. Then we have OSI model. Then we have TCP IP updated model. UDP is not a model. These are the protocol, TCP and UDP, those are the protocols. Right now we're discussing models. Okay, so this TCP IP original model, you can also call it as a DoD model, means Department of Defense model. Okay, now what all are these models? These models are nothing but set of documents only. All of these models are nothing but a set of documents. Okay, these are nothing physical, only documents. Now, in these documents, what is there? There are certain protocols defined. In these models, there are certain protocols defined. What is a protocol? Set of rules. Set of rules. Okay, and these protocols are what? Set of rules. So what is a rule? Kind of instruction, right? So what these rules define? These rules define how your network communication will take place, how your devices are going to work. Okay, let's say, for example, we have a rule here that, okay, we have to start the class at 8 and then we have to take it till 10, and some other set of rules are there. So what are these? These are the protocols that we have, some protocols here. Okay, similarly, we use devices like hub, switch, router, we have monitor, keyboard, mouse, everything we have. Everything is communicating with each other. But how they are communicating? With the help of these rules. These rules define that how they are going to communicate. Okay, how they are going to function. Is it clear? Okay, now see, all these models are just a set of documents, and these documents, in these documents, certain protocols have been defined. Okay, and these protocols are nothing but set of rules, and these rules define how your network devices are going to function, how they are going to work. That is clear? Okay, means these models help us understand the backend process of communication, how the communication is happening. So if we understand the backend process of communication, then after, if there is a problem in the communication, we can easily troubleshoot also, because we already know that, okay, at which stage of communication, what is happening. So we can easily troubleshoot also. So they help us in the understanding of communication as well as troubleshooting part as well. Clear? All right. Now, out of these models, right now we will see just a small introduction to the OSI model, not a detailed one, just a small, like what we need to understand here. In case of OSI model, okay, this thing, no need to note down right now. You can just understand, because one separate session we'll have for OSI model. So in case of OSI model, see, it is also going to help us understand. There are total 7 layers. The communication has been divided into 7 layers. Now, these layers are application, presentation, session, transport, network, data link, and physical. Now, the numbering of these layers will start from bottom to up. So whenever you are asked what is a layer 1, your layer 1 is physical layer. What is layer 2? Your layer 2 is data link. What is layer 3? Network. What is layer 4? What is layer 5? Session. What is layer 6? Presentation. What is layer 7? Now in the hub, it is written hub is a layer 1 device. So which layer device it is? Physical layer device. Okay. So whenever we'll say hub is a layer 1 device, that means, okay, we are discussing about OSI model layer 1. That is the physical layer. Okay. Now, few things are mentioned here. Let's say these upper layers, they are known as software layers, like application, presentation, and session. Why? Because the task of all these three layers are done by an application software. Let's say you are using WhatsApp. You're using WhatsApp to type in a message, hi. So that is an application. The task of presentation and session, all these things will be done inside your WhatsApp application itself. Okay. We'll understand what are the different tasks of these applications and everything. But right now, just understand then the task of these three layers, 5, 6, 7, application, presentation, and session is done by a single application software. That's why these are known as software layers. Is that clear? Then bottom three layers, these are known as the hardware layers. Why? Because on these layers, we use physical hardware device. Let's say if we discuss about your physical layer, in physical layer, you use hub, you use your network cables. These are part of physical layer. Data link layer, your switch is a layer 2 device. That is a data link layer device. Network layer, your router. Okay, these things will be clear when we discuss what are the tasks of these layers. But as of now, we need to understand that, okay, when I say hub is a layer 1 device, means it is used at the physical layer. When I'll say switch is a layer 2 device, that means it is used at the data link layer. And when we'll say router is a layer 3 device, that means network layer device. Okay, so here we are using physical devices. That's why these are known as hardware layer. And this transport layer, heart of OSI. Why? Because this is the, you can say this is the layer that is going to provide communication between the software layers and hardware layers. Plus, your end-to-end communication will also start at the transport layer. It uses two important protocols of communication, TCP and UDP. Okay, these are the protocols it uses. So we'll discuss about these things in very detail. We have separate session for OSI, separate session, one separate session for TCP and UDP itself. Okay, so one by one we'll discuss. These things are clear. So right now, when I will say in the hub, we will say, okay, hub is a layer 1 device. That means physical layer device. Okay. Then small introduction to the type of addresses also. What is an address? Okay, not talking about IP address. What is an address? A unique identity. Why we require an address?
To reach the place.
To reach the place or to identify it? Address is just used to identify, right? Now, how we are going, that is a different part. Okay. So address is a unique identity that is used to identify a node. Address is a unique identity that is used to identify a node. Now, we have two types of addresses. One is the logical address and second is the physical address. What is logical and what is physical?
Logical we can change anytime, but physical will not change that.
Okay, logical we can change. Physical.
Cannot be.
Logical comes from the logic, and logics can be changed. Okay. So logical addresses, these are, you can say simply these can be changed. Okay. Can be changed. Or you can say these are not fixed addresses. Okay. What about physical address? Cannot be changed. These are fixed. Let's take a small example for this. Let's say, for example, you enroll in a university. This is a university. Now, in this university, if someone has to identify you, you can be identified with two things. One is your name, and second is your enrollment number. Correct? Yes or no? Okay. Let's say from one university, you go to the second university, you enroll in the second university. Now, Here also you can be identified with two things. One is your name and second is your enrollment number. Okay. When you walk from one university to another university, will your name change? No. What about the enrollment number? Why your name will not change and your enrollment number will be changing? Why? Fixed with you. For you, that is the fixed identity that your name is this. Now it cannot be changed. But your enrollment number can change. Okay. So means here, this is the physical entity that is fixed with you. That if you are there, your name is this only. But enrollment number depends on the university. Enrollment number depends on the university. So see, now when we're saying can be changed and cannot be changed, what does it mean? It means when you are traveling from one network 1 to network 2, what will happen? Your logical address can change. And type of logical address is IP address. But your physical address cannot change. Example of your physical address, MAC address. Now, why your IP address will change and why your MAC address will not change? This is also a question. Because see, let's say if you are connected to home router and if you check your IP will be something like 192.168.0.1, something like this. Okay, let's say 0.10. This will be your IP. Now, if you come to NH and connect to the NH Wi-Fi, let's say here we are using the network 192.168, or let's say I'm using some different network here, 172.16.0. This network I'm using. So you will get an IP from this network because you are connecting to my router. In my router, I have configured that I will be using this IP range. See, at my home, I'm getting this IP. Okay. And if I see here, then I'm getting something like this. So this thing is depending on what? This thing is depending on to which network we are connected. Okay. So whenever you travel from one network to another network, your IP address will change. Now, why your MAC address will not change? How physical? Where your MAC address is situated? Where it is located? Inside your hardware. When we are talking about hardware, if you are connecting to the cable, it is fixed with my cable port. If I'm connecting to Wi-Fi, it is fixed with my Wi-Fi card. It is the identity of that Wi-Fi card. Okay, if I change the Wi-Fi card, then it will change. Okay, but do I change my Wi-Fi card every time? No, that is fixed. I purchase a laptop that is connected inside. I'm never going to change it. That's why your physical address do not change. Right? When you take your phone, a MAC address is binded with your phone. Now, if you connect to here Wi-Fi here, your MAC address or your phone will still be same. If you connect at home, your phone will still be same. You have the same device, you have the same hardware. Okay, so that's why your MAC address will not change. Is that clear? Because see, your physical addresses, these are hard coded with the device. And these are not hard coded with the device. So these can be changed. Yes, ma'am. Clear? Address is understood. Now, when we discuss about layers, okay, so your IP address is a layer 3 information. Your IP address is a layer 3 information, and your MAC address is a layer 2 information. Layer 3 means network layer, and layer 2 means data link layer. This is clear? Okay. Now let's move on to our first device, that is your hub. Okay. So the first point in the hub is a layer 1 device. What does it mean with the layer 1? Physical layer. That means we are discussing about OSI model layer 1. So hub is a physical layer device. Okay. Second point is, what is the second point? Hub is a dumb device. Why it is a dumb device? What do you mean with a dumb? Who doesn't know anything? That is dumb. Right? Not an intelligent means. See, how do we decide whether intelligent or not? Like about a student, how do we decide? If he knows something, he's intelligent. If he doesn't know anything, he's dumb. Right? Similar. Hub doesn't know anything. That's why he's a dumb device. It's a dumb device. So what your hub doesn't know? Let's say I have connected all these nodes to the hub. Okay. Let's say this is, for example, device 1. This is device 1, 2, 3, 4, and 5. These are the 5 devices. And on the hub, they are connected on the ports port number 1, port number 2, port number 3, port number 4, and port number 5. Okay. Now let's say this device 1 wants to communicate with device 5. Device 1 wants to communicate with device 5. So who is the source? Device 1. Who is the destination? Device 5. Right? Now this information will be delivered to the switch. Now here only one sender, one receiver. What kind of communication it is? Unicast. Correct? This is a unicast communication. Okay. Now the message has come to your hub. Now your hub doesn't know on which port what device is connected. Your hub doesn't have this information that on which port what device is connected. So what your hub is going to do? Let's say, for example, you are in the classroom. Now someone comes and deliver you a letter that, okay, this is for this student. Now, do you know the student? No. So what you're going to do? You are going to call out his name. Correct? So when I call out the name, what kind of message it is? Broadcast. Because everyone will listen. So same thing your hub is going to do. Your hub will make a blind guess. Your hub will say that, okay, I do not know where what device is connected. So I'll do one thing. I'll send it to everyone who is the legit receiver. They will take it and rest of them will be dropping. So your hub is going to send this information to everyone. Okay. Now what is going to happen? Everyone is receiving this information. And what kind of information it is? Unicast. So what if there is a broadcast message? Even your unicast message, your hub is broadcasting. So obviously it is always going to broadcast only, right? So here you can take up a point that your hub is always broadcasting. There is no unicast multicast concept in the hub. Hub is always broadcasting. Then your hub has a single broadcast domain. Broadcast domain, we understand. What is a single broadcast domain? Only one broadcast domain. That means all the ports of your hub, they will be part of one broadcast domain. Means if there is any broadcast message on any port of the hub, that message will be delivered to everyone. Okay. That message will be delivered to everyone. And we already saw that if it is a unicast broadcast, any kind of message, your hub is sending everywhere. Because your hub is always broadcasting. So your hub has a single broadcast domain. But there's one more thing. Your hub has a single collision domain also. Your hub has a single collision domain also. Now what? See, collision domain. What is a collision domain? What is a collision domain? Network or part of network where there is a possibility of collision. Now let's say these many ports are there on the hub. And all of these ports belong to the same collision domain. They belong to the same collision domain. So this is a kind of situation that, okay, you are having roads from every side like this. As many ports, how many? 1, 2, 3, 4, 5, 6, 7, 8. So your hub is like a junction. Now, if some traffic wants to go from this side to this side, 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 what will happen if everybody start going at the same time? There will be collision. There will be an accident, right? There will be collision. So what can happen here? If at a time, one side communication is allowed, let's say if traffic is going from this side to this side, no collision. 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 Okay. Now let's say what will happen if the traffic is going this side to this side at the same time the traffic came from this side? There will be collision. And if the collision is there here, will any traffic be able to pass? No. Correct. Same thing is there with the hub. Means at a time only one communication is allowed. And when we allow only one communication, that is half duplex. We can have two-way communication. The traffic can come from this side to this side as well as from this side to this side also. But at a time, only one-way communication will be allowed. Okay, so that's why your hub is a half duplex device, and having a single collision domain means only one junction, you can say. Okay, you can say kind of your hub has a single channel for transmitting the information as well as for the receiving of information, only one channel. So if one-way communication is happening, that is fine. But if at the same time two-way communication is happening, that time what will happen? Collision will happen. Okay. Now how this thing will work? So let's say PC1 wants to communicate. This PC1 wants to communicate with PC5. What your hub is going to do? Send it everywhere. Correct. But when PC1 wants to communicate with PC5, let's say at the same time, this PC2, this is PC2 wants to communicate with PC4. This is also sending the information. What will happen? Two informations are entering this hub at the same time. Now hub has to deliver both the information on both the ports. What will happen? The signals will mix up. It is kind of, let's say, for example, from this side power is coming, this side power is coming, and you connect the wires. What will happen? Sparking. Okay, same thing here. These two informations, they will collide with each other. The signals will mix up. And when the signals will mix up, there will be no relevant information. Okay, means there will be a collision. And when there is a collision in the hub, all the ports will go down. Means your entire hub will go down. Okay, let's say if there is a collision on this port, port number 1. So remaining all other ports will also not have the communication. If there is a collision on the hub, your entire hub will go down and there will be no communication at all. This is clear. Noted? Okay, let's move on to the next device. Switch. Now switch is a layer 2 device. What is layer 2? Data link layer. Correct? This is a data link layer. Your switch is an intelligent device. Now, how your switch is an intelligent device? That means your switch can store the information that on which port what device is connected. Your switch can make some forwarding decisions. Okay. And if we discuss about your switch makes forwarding decision based on the MAC address. Okay. Switch makes forwarding decision based on the MAC address. Okay, means your switch is going to create a table here. Okay, what kind of table? In the table, MAC table. Okay, in the table, it will have the information that on which port what MAC address is connected. Okay, and this table has two names. One is your MAC table, and you also call it as a CAM table, content addressable memory table, because this MAC table is stored inside the CAM. Okay. Now let's say again port number 1, 2, 3, 4, 5, 6, 7, and MAC address is having, let's say for example, this is M1, M2, M3, M4, M5, M6, and M7. Okay. So your switch will keep the information on port number 1, M1 is connected. On port number 2, M2 is connected. On port number 3, M3 is connected. On port number 4, M4 is connected. On port number 5, M5 is connected. Port number 6, M6. Port number 7, M7. Okay. Now let's say this PC1 wants to communicate with PC4. Okay. So who will be the source? M1. Who will be the destination? M4. This message will be delivered to the switch. Now, first of all, your switch will check the destination. Where is the destination? M4. Then it will check in this table that for M4, on which port I need to send the data? Port number 4. Okay, I will just send it here. Is it a unicast or multicast or broadcast? Unicast. Why? Because from the sender, the information has reached only M4. When M4 wants to reply, M4 will say, okay, source is M4, destination is M1. This message will get delivered to the switch. Switch will again check what is the destination? M1. So for M1, which port? Port number 1. Deliver the information this side. Again, unicast communication. One-to-one communication. No other port is receiving any kind of information. This is clear. So that's why your switch is an intelligent device, because it can make the forwarding decisions. Then after, your switch has single broadcast domain. Single broadcast domain means all the ports of switch, they belong to the same broadcast domain. So if there is any broadcast on any port of the switch, your switch is going to deliver that information to every other port. Okay. So if any of the systems, let's say for example, your PC1 creates a broadcast, so that information will be delivered to all the ports. Why? Because all ports belong to the same broadcast domain. One switch, one broadcast domain. Then per port collision domain. Now, what does it mean with the per port collision domain? So earlier when we were discussing single collision domain, that means we had only one junction. Now we are saying every port is a separate junction. Every port is a separate junction. That means it is kind of two-lane highway. Means there is one channel for transmitting the information and there is a separate channel for receiving the information. Is there any chance of collision? No. So that means we can have two-way communication at the same time. That is why switch is a full duplex device. Is that clear? Okay. Noted? Huh? Then we have router. Router is a layer 3 device. Layer 3 means network layer. Your router is also an intelligent device, means router can also store the information that, okay, how to forward the packets. So if we discuss about your router make forwarding decision. Router makes forwarding decision based on IP address, because IP is a layer 3 information, right? And this is how your router looks like. Take it on the table. So this is how a router looks like. Enterprise router, not like a home router anymore. This is how it looks like. Okay. This is a router and these are the switches. Okay. We'll be going to the lab, okay, and we'll be seeing how to access these devices and how to make the configuration. But for that part, we'll have to wait for some time because we need to understand how to do the basic configuration now. And after that, we'll go to the lab. Okay. Then after, your router has per port broadcast domain. Per port broadcast domain. So means if your router has 2 ports, 1 and 2. So both the ports are in different broadcast domain. Different broadcast domain means if there is broadcast on this side, if there is a broadcast on the one side, that broadcast message will never go to the other side because that is a different domain. That is a different part of network. See, when we say broadcast domain, so this classroom is one broadcast domain and the nearby classroom is a different broadcast domain. So what information I'm delivering, that will remain inside this classroom, and what information is getting delivered that side, that will remain in that classroom. So that is what a per port broadcast means. Each and every port is a different broadcast. Okay. So if there is a broadcast on one port, that will never be forwarded to the other port. So make sure you remember and also note down your router will never forward a broadcast message from one port to another port. This will be really useful concept. Okay. Later on, we will need this concept that your router will never forward a broadcast message from one port to another port. Why? Because per port broadcast domain. And similarly, it has per port collision domain. Okay, per port collision domain means separate channel for receiving and transmitting the information. So that means two-way communication at the same time is possible. So it is a full duplex device. Is that clear? Router will never forward a broadcast message from one port to another port. Router will never forward a broadcast message from one port to another port.